So there you go. Go for it. That.
Oh.
It was up when we walked.
I know, but I just took it off, and they're like, "Can you put it back? Can you put it back? Can you put it back?" Later, Cynthia.
Thank you. Bye.
You guys, that was all her. I already had the equation written down. I was just gonna do it.
Okay, big
Wow.
Good.
Nice.
It's a good thing to know that.
This tastes like you know, like the cherry gummies. It tastes like the liquidated version.
Not that bad.
Where the heck is not a struggle? I should never hear. Struggling this morning.
The struggle is struggling.
Yep.
All right, have a good day struggling through it. Good morning, ladies and gentlemen. How are we doing today? Wonderful. Grab a piece of scratch paper, copy this one down, try to balance it. It's going to take a little bit of work, ladies and gentlemen. Okay? It's going to take a little bit of work. If you follow the rules, if you add things up correctly, you will get it to balance. Okay? And I will tell you, very important in this one is that one trick that I told you about. Save the lone elements for last.
Oh shoot! I remember wrong.
Okay? I'm not saying you have to, but I think to me it's a little bit easier when you do, but you can. So, all right. Take a minute. Get it done, ladies and gentlemen. Let me get some attendance taken and things.
Like you said.
No, I actually started.
I did that like second.
Did you get the sandwich?
Yeah.
Okay.
I don't know how to do it. Why do you skip to the part where you explain?
You can't say you don't know how to do this because there is no set way of doing it. It is about setting up your scoreboard, figuring out how many are on each side. And the side that needs more of something, you have to put it there.
Where's the line?
If you follow that, you will get this to balance.
You didn't see it. You don't know what I mean. Like the one.
The old Jedi mind trick does not work.
Yeah, why?
I mean, like, I get it. It should be. Sorry. Oh my god, I recorded a long video. 43 seconds.
Oh my gosh, you got about 2 seconds to put that away before it goes into the cabinet. 1, 2, away. Away.
Okay, how do you do this?
No, where you can't see it.
I can't. If I'm looking up, I can't see.
I got a place where you can't see it. Zip it up.
There probably are. People.
Two choices. Zip it up or put it in the cabinet. Actually, I'll give you three. You
Why
can
do you
take
look
it
like a
down to the
highlighter today?
Because I'm just that bright. I am that bright every day.
That's not true.
So how far have you gotten?
Nothing.
Good. Then start with something.
Well, I don't know.
Well, here's what I will tell you. Again, couple tricks you can use, ladies and gentlemen. Number one, start with something that there is only one way to balance it. What I mean by that, don't start with oxygen. It's all over the place. We can't ignore it here because it's not everywhere, but don't start with oxygen. So start with calcium. Why? It's here and it's here. There's only one way you can get calcium to balance. One way. So balance it. Balance it. Don't do carbon, don't do phosphorus, don't do oxygen. What does that leave you? And calcium. Start with calcium because silicone is already balanced. After you have balanced calcium, do one next. Again, trying to avoid oxygen, carbon, and phosphorus. So I would do silicon after I did that. Calcium. Then, ladies and gentlemen, now you've got to do either carbon, phosphorus, or oxygen because they're the only three left. But again, if you start with the one that you have to start with, the one where there's only one way to get it to balance, that is a great place to begin this problem.
What's your attitude?
I certainly can. Hang on one second.
Is that right? What is this?
Do you have the same number?
I almost.
But I like.
So I put 3 right here. So this would be 6, right?
Yep.
And then this would be 8.
I mean, unless you
It's
double.
Natus 14 last time I checked.
So then I have to change this one.
5 is.
And how do I fix this one? Do I have to?
Okay. You need more oxygen on this side, right?
Yeah.
That
Well,
it?
you can't change the number here, correct? So
This
where else
isn't
is
one.
oxygen on that side? Get it to balance.
Why are they not doing it?
Just to see, then I have to go back.
Oh my gosh, yes. Oh my
It's not
gosh.
hard for you. I mean, it's not hard for
Wait,
me.
what?
Just do it.
I had it.
Yeah.
Okay, but no, what I literally knew it from the.
I don't know.
Okay, buddy.
I don't know, but put the number there.
I literally knew it from day one. I literally knew it as soon as I walked in this room. I've known it since 3rd grade. Literally nothing
So
is
you gotta
hard.
figure out what number
That's
you
why
gotta put
I
there.
have an A plus in this class. Yeah, nothing is hard for me. I told you
Now
that's
you
why
gotta
I'm
come
A
with the other
plus
You
in
gotta
this class.
you gotta go scout it up to see if you've got a balance or not.
You're like, don't say that. You're right on the mark.
All of those things, yep.
You can see my A plus. Actually, I don't know if I'm back to a B or not, but I was not in the B for a while.
3 times 3.
Because I'm not good at this class. This sucks. Hey, did you fail a master's?
Gotta get that to balance.
You did? See, it's hard.
Now update
One
everything.
fail doesn't mean it's hard.
And then it's gonna be another
Play
fail.
solitaire with, like,
Not
You have
another
the
fail.
same number of beats on both sides?
I know.
it's hard.
But yesterday we
Okay.
counted wrong, so.
Why do you think that this one didn't hard if that's just.
Yesterday we counted wrong.
I counted.
That, oh my lord.
No, I tried to recount it and I still counted wrong.
It looks pretty good, yes. Wait,
Did you like that
out of sight, out of mind.
No, because I know it is an A plus.
How many oxygens do you have here?
Then it's not funny.
Whoops.
Mine is funny because
You
I
copied
don't
the
have-
formula down wrong. SiO2.
I know you literally have.
So that's gonna change this. So then you do a little bit more chocolate. Okay. So after you balance the calcium and after you balance the silicon, you probably want to balance the oxygen. Double check it now because you need to change that.
I don't know what I do.
You need to double check your math here.
I still got 10, but I had to take 19 because I had switched this one.
Count up your oxygens on this side because they're not quite right. Count up your oxygens more carefully because they're not right.
Actually,
I have 14 of those
why did I
things.
put yeah?
Yeah.
Sorry, my
There's
bad.
only one
My bad. For both of my bad.
on the left side, and there's one on the right side.
Oh, I think I turned it.
Maybe you should count up your oxygen.
Maybe I should.
Start over with the second one.
Shoot.
No, too late.
Just look at mine.
Your B.
My B. My B.
It's funny.
Yes.
It sounds a little like he's making fun. But I don't know why. Maybe it's just a regular.
You are. You have to.
Just start your chart over here.
It is.
Why'd you get 10
How much is that?
There's only 2.
You're going to
Oh, that's right. Because I only put 4 numbers here.
Oh, yes.
Yes, you are. Okay, well, is there oxygen someplace where you can change it without charging?
No, we're reading with like 5 people, so it's like not
Where else is oxygen? On this side, somewhere else. Okay, so you're gonna have to put a number in front there to increase your oxygen. So you can get it.
What the heck?
They're very close, they're close.
Solo cambiarías.
Is that right?
¿Sabes qué? Está hablando, güey.
Is everything the same on both sides? Then yes, that's right.
¿Sabes qué está hablando? Okay, you said
Sí. What?
I was trying to check Nadia's, but she keeps
Pero es
putting
que
her
no
hand over the top
cambiaríamos.
of it.
Because she erasing because she messed up.
Oh, sí.
Ooh, she messed up.
What the heck?
She messed up.
You mess up all the time.
For real. In the worksheet.
Wow, I told you ages getting to that.
At least I have an excuse.
Okay, I don't. I'm
What's
not
your
making an
excuse for
excuse.
messing up all the time?
Don't. I know that you're gonna go. Miro. No, he does not want to see your fake A+++.
That's a 200.
You can tell that he's about to talk.
You did, I did, I did. You
I
did.
can see him.
Yeah, let's double check your math on your oxygen. Sorry.
You remember the
On
one
both
time
sides.
at
Double check.
Stobo when you said that I smell like basil? That was weird.
All right.
Yep. That was weird.
So let's go through this, ladies and gentlemen.
That's literally what she was saying.
Weird.
I will tell you this. This is probably tougher than anyone you will be asked to balance on your, definitely on your quiz tomorrow and probably in this unit. And what makes it very difficult to balance is the fact that you've got a lot of things in a lot of different spaces. Okay? So you've got 3 reactants, you've got 3 products, you've got a lot of different things going on here, but our process doesn't change. Okay? So again, underneath our arrow, ladies and gentlemen, we would set up our scoreboard. Now, the reason I do that is so that you can keep track left side to right side of how much is on each side. It's just the way I do it. You can do it however you wish. But for me, I do it this way because it makes the most sense. So I do Ca, phosphorus, oxygen, Si. I don't need to list the O again because I've already listed it, and carbon. Now, when you start out doing this, again, 3 calciums, 2 phosphorus, 8 oxygens here, 2 oxygens here for a total of 10. 1 silicon, and 1 carbon. On the product side, 1 calcium, 1 silicon, 3 oxygens here, and 1 oxygen here for a total of 4, 1 phosphorus, and 1 carbon. Now, there are 3 things that need to be balanced. There is calcium, there is phosphorus, and there is oxygen. You technically can start wherever you want. But my caution to you, my warning to you, I'm going to say phosphorus for the end. Why? Because I can put any number I want in here and I can get it to balance. I do not want to start with oxygen for one simple reason. With it being in 2 spots over here, I don't know where to put a number to get it to balance. I could put a number here and here. I could put a number in one spot or the other. That makes it a little bit more difficult. So I'm going to start with calcium because there's only one way I can get it to balance. And it's also going to change other things with it. So I'm going to put a 3 in front of the CaSiO3. That 3 gets my calcium to balance. It does, however, change the Si, and it changes the oxygen from 3 to 9 here, sorry. So for a total of 10. So now, again, I could still balance the phosphorus, or I could balance the silicon. The oxygen happens to be balanced now. Ladies, stop, please. Okay, so I'm going to balance the silicon because, again, I have to put a number here. And since it's with something else, that's going to change things again. So I have to put a 3 here to get this to balance. That's the only way it can be done. So now instead of 2 oxygens, there are 6 here. That makes this 14. Now, I've only got 2 things left. I've got phosphorus and I've got oxygen. I know I can balance phosphorus. Boom, I'll put a 2 here. There, that's done. But I still have to balance oxygen. And everybody's like, well, I already put a number here. You're right, you can't do that. But there is another spot where there is oxygens. Now, I need to put a number in front here to increase this to 5 oxygens so that 5 and 9 can give me 14. So I'm going to have to put a 5 in front here. Okay, that makes this 5. Again, that makes this 14 for those of you who did the math correctly, unlike I did the first time in my head. That's what you should have gotten. You also changed the carbon to 5. Luckily, carbon's alone over here, so I can put this 5 in front of it. And you're done. You've balanced it. This is about as difficult as it is going to get for you. Okay? Are there ones out there that are harder to balance? Yes. Or am I going to give any of those to you? No. Okay? No. But again, the process that we go through, if you follow the steps that we're teaching you, it will help you along the way. But if you don't like the steps that I'm teaching you, I don't care how you get to this. As long as you get to this. Okay? As long as you get to this, that is the main thing. Questions? Okay. If you would, take out your computers, get logged in, get into your EISN. While you're doing that, since we started with this, ladies and gentlemen, I get to now go back to this, which is, all right, here's our plan for today. Our plan for today took a little bit of a turn, thanks to, well, I won't point out Cynthia, but thanks to Cynthia, who's like, put that back up, I want to work on that. Okay, go ahead. Thank you, Cynthia. Nothing. You've got a quiz tomorrow. There are 5 questions on it total. 4 of them you have to balance a chemical equation. Because that's what this unit is about. And I want to see if you can do it. So I'm asking you to do it on the quiz. So you have 4 equations that you have to balance, and then you have to know the parts of a chemical reaction. What do we call the things before the arrow reactants? What do we call the things after the arrow products? Okay? What are these little numbers called? What are the big numbers out in front called? And this one didn't have it, but the little symbols afterwards. Those are your states of matter. Solid, liquid, gas, aqueous, crystalline, solid, metal. Now, metal is not a state of matter, but we're identifying that. But if you were to tell me that those things represent states of matter, I would be fine with it. Okay? States of matter are how that substance is, either way. Okay? So that is your entire quiz tomorrow. Questions?
What are the big numbers called?
The big numbers out in front are called coefficients.
What are the little numbers?
The little numbers are called subscripts.
Oh, just like the. Okay. I thought there was like a special name for it.
Nope. These are subscripts. The number out in front is a coefficient. And if we ever did something like this, this is called a superscript. Please remember, superscripts end up being crisscrossed and become subscripts in our compounds. So calcium is a +2, phosphate is a -3. That's how we get the Ca3PO42 here. We take our superscripts and crisscross them into what are called subscripts. Super means above, sub means below. Questions? Today, ladies and gentlemen, excuse me, we are going to look at single replacement reactions. Okay? I will give you some more time to work on that worksheet, especially where we are taking the names, writing formulas for them, and then balancing them. You do not have to do that on your quiz tomorrow, but that is going to be an important thing for later on, especially in the second half of this class, in the second trimester of it. And again, 1 week from today is the last day for any missing work, any retakes that you want to do, anything that you want to do to improve your grade going into the final exam. And the final exam is going to be a lab exam. So you're going to be doing a lab in the day of the final that will take the place of the final exam. Questions?
What's the test?
Yours is first hour will be on the 28th at 7:30 in the morning. I'm surprised they haven't come out with the schedule yet, but I'm sure they will very shortly.
No. The test, the unit test. There's
There isn't one.
what? There's not a test.
Did I've told you guys this before, right? Okay, thank you. There's not a test for this unit, Cynthia.
So this unit is going to take us all the way to the end of the trimester?
Cynthia, 2 weeks from today, you will be done.
Oh, shoot.
Bang.
Sure. That literally just gives me PTSD.
So 2 weeks from today, you're done. 2 weeks from today, Cynthia, you'll only need to see me for 12 more weeks.
Thank
12
the
more
Lord.
weeks. Don't thank him. Thank the school board. They make the schedule.
Thank
Okay.
the Lord.
Miro, that was awesome. Absolutely awesome. Absolutely. Wonderfully done. It's like you two were working together on that. That was incredible. Nicely done. Questions? Okay. Wow. This is going to be a good day, ladies and gentlemen. This is going to be a good day. All right. So here we go, ladies and gentlemen. Slide number 19. Slide number 19. Our third type of chemical reaction is what is called a single replacement reaction, ladies and gentlemen. Okay? Now, single replacement reaction. is a reaction. Come on. In which an element takes the place of another element in a compound, creating a new element and a new compound. So it's not as easy anymore as looking for the side where there's not a plus sign. No plus sign after the arrow means that it is synthesis. No plus sign before the arrow means that it's a decomposition. Now you've got a plus sign on each side. Now you need to look further at it. In this unit, our compounds are normally ionic compounds, which means they are made up of what? What kind? There are not ionic elements. Elements can become ions. What are the two types of elements on the periodic table? And what is an ionic compound between? A metal and a non-metal. Okay? So here is the general formula for a synthesis, or I'm sorry, a single replacement reaction. By the way, you may hear it called single replacement, you may hear it called single displacement. Okay? You have a element and something that is a compound. And on the product side, excuse me, you will have a different compound and an element. That is what a single replacement reaction is. You have one lone thing and something that is together. Cynthia, get up. Get up. Get up. Move. Cynthia just experienced single replacement reaction. What was the compound?
You were the compound.
No, I was not.
The chair and the human combo.
The chair and Cynthia were the combination. I was a lone element just standing there. I have now replaced her. She is now the lone element. I am now part of the compound. That is a single replacement reaction.
Woo!
You want to continue or you want me to?
Oh, you can.
You sure?
I want to say.
You want to sit? Wow. Okay.
That I learned so much from that.
That was great.
That was crazy. She just got replaced like that.
Yep.
Wow.
So what's replacing what here?
Elements.
What element is replacing what element?
Zinc is replacing
Copper.
Copper. Zinc is replacing copper, going into the compound with nitrate. And now copper is a lone. Okay? Now please remember, copper has a charge when it is in the compound, correct? Zinc has a charge when it is in the compound. We still need to balance off these compounds. In this case, copper happens to be what charge? +2. What charge is zinc? +2. So therefore, it both combine with two NO3s. That isn't always necessarily the case, ladies and gentlemen. Okay? So what I have here, ladies and gentlemen, is I have some copper metal. Copper wire. Twisted around. Okay? And in here, ladies and gentlemen, I have a compound called silver nitrate. Describe the silver nitrate. Clear. Liquid. What color is it?
Colorless.
Don't say clear. Clear is not a color.
It's colorless.
Colorless. No odor. Let's put the copper metal inside there. And what has happened?
You
Yeah, nothing, right?
Wow.
Woohoo!
Freaking out.
Great example, Mr. Brand. Good job. Way to excite us. Way to thrill us. Way to make something happen, ladies and gentlemen.
Wait, do it again, I didn't see.
Anything happening?
Can I taste it?
Can you taste it? You want to lick the copper?
I mean,
Not the
Woo,
copper.
lead poisoning.
no, the cover
That's
makes
not.
and lead.
Did
What?
I was kidding. I was kidding. Please stop. He's not just kidding.
You're not going to get lead poisoning. However,
I
copper is
was
still a
kidding.
heavy
I
metal.
was joking.
Heavy metal.
Confidence.
I like heavy metal.
Cynthia's snorting. She's not. Don't snort again. Stop. Stop. You're going to snort.
No, I'm not.
Yes, you are.
Why is it actually
Yes, you are.
time? Calm down.
I'm sorry. Do it.
Stop.
Don't do it.
You're gonna do it again. Please
Don't do it.
Please.
Right.
Now, oh my God! Listen. Use your brain.
Use your brain.
That's poisoning. When I said it sounds like he's talking about a crime, and then you said it sounds like
Hello,
we're
Christian.
Shut up. You're like fools.
Hey, was
Every time
anything
I say
happening
something,
when you
she
guys
just
saw it?
listens louder.
No.
It was bubbly.
I don't know. Is anything happening?
Yeah, there was something happening.
Did the copper leave? The
The
water.
copper's starting to look fuzzy.
It's starting to look white.
There's like bubbles around it.
What?
Suddenly you just drunk.
Oh.
We're starting to look a little fuzzy.
Copper's starting to turn a little bit white, ladies and gentlemen. Copper's starting to turn a little bit white.
It's getting moldy.
Like your hair.
It's getting moldy.
Oh boy.
Cynthia,
That
was it Nadia?
Yeah.
Nadia,
It's always
it
Nadia.
really doesn't matter to me because I've always lived by one simple phrase. It's better gray than gone. So
Yeah.
I
I
hope
mean,
that in the next year your hair.
I don't know how I would look with the Mr. G
I
hairstyle.
hope in the next year you go completely bald.
Actually, probably not in my DNA
And then you
because my
switch it and
grandpas
you go
were both
better
well
bald
into
than
their
gray.
80s, had full head of hair. My father had a full head of hair all of his
Yeah,
life.
you're gonna be the only one.
It could be, but it hasn't happened yet.
And you're gonna go.
What?
That's your mother's dad.
And as I said, both of my grandpas had full heads of hair all of their lives.
And you're gonna go better bald than gray. You're just gonna switch it up.
Well, I'm going to have to at that point. So, okay, here's what's going on inside that container, ladies and gentlemen. Copper metal was put into silver nitrate. Now, what form was the silver nitrate in? Actually, no, it's not a liquid, but you're close. It is aqueous.
Okay.
Now, the difference between that is silver nitrate is actually a solid, like a salt. And when you put it into water, it becomes aqueous. It dissolves. Okay? All right. So, if a reaction is happening here, ladies and gentlemen, what has to be changing places with what?
Copper with the silver.
Why the copper with the silver?
They're both the metals and the
Thank you. So one of the things that you need to understand about a single replacement reaction is if one thing is going to replace another in the compound, they have to replace something that is similar to them. So for example, copper can only replace silver. It cannot replace the NO3 part.
Why not?
Because then you would have copper and silver together, two metals together, and two metals can't combine because what kind of charge would both have? Positive. And the total charge on the compound is?
zero.
0. No way you could get a 0 charge if you have two positives together.
So we take out a non-metal, we have to replace it with a non-metal. If we take out a metal, we have to replace it.
Correct. And 90% of single replacement reactions will involve changing out the metal, not the non-metal. So normally it's going to change out the metal, the first part of the compound. So this copper is going to go and replace that silver. So what are our products?
Silver
Silver metal.
plus copper nitrate.
Okay, copper will be a +2 in this. So what would be the formula?
two. Yeah, I agree.
Okay, here's the next thing, very important for you for now and for next trimester. Single replacement reactions. Metal or a gas, aqueous, compound is always aqueous. The compound in a single replacement reaction is always aqueous. The lone elements can be either a gas or a metal. Now, normally if it's a gas, the gas is on the product side. Okay? And since it's normally a metal that replaces a metal, what is the only gas that could be created? What? Hydrogen gas. Why? Because hydrogen can act like a metal. All of the other gases happen to be nonmetals. So hydrogen gas can be a product in a lot of single replacement reactions. Okay? Can be the product in a lot of single replacement reactions.
You're right, mercury as a metal or a liquid.
Well, mercury you could do as either. Because at room temperature, it is a liquid. However, it is a metal. Okay? Tweedledee, Tweedledum. Do I need to separate you two?
Oh,
Well, what did we just talk about?
single replacement is always aqueous.
Okay, it's good to know you weren't listening because the question was, do we write mercury as a metal or as a liquid? But again, now that you're talking to each other because you're back on good terms or whatever, now you're not listening to me. Stop it!
We got back together.
Good, fight again so you'll listen to me. So, this is what we got, ladies and gentlemen. Okay? Now, you will sometimes put a metal with a compound and nothing will happen. The way we can predict this, ladies and gentlemen, take out your second sheet that I gave you, your second pink one, not your periodic table. Now I need your one that says solubility of ions reference sheet and activity series of common metals. If you don't have one, it's in the second black tray down over on that file cabinet.
This one?
Does it say activity series of common metals on the top?
Maybe.
Okay, does it say solubility of ions reference sheet on the top?
Maybe.
Well, I can't help you if it's not one of those two. I'm sorry.
I just got a defective one.
Right, you got the one out of the copying machine that didn't put the title on it. Yes, that's a very distinct possibility. Yes. What? Correct. It is a liquid at room temperature. As a liquid instead of a gas, it would be a liquid that's created. Yeah. Now, those are great points, Levi and Leaf. Both great points. But here's the fact. In the 26 years I've taught, I've never had mercury be created as a product or bromine be created as a product. I'm not saying it can't happen. I just try to avoid exceptions like that for you. Okay? So again, metal and a metal normally, aqueous and aqueous normally. Actually, aqueous and aqueous always. Okay, so does this reaction actually occur? Does this reaction actually happen? Well, you tell me, is something happening here?
I literally cannot see it at all.
It got moldy.
We got moldy already.
No, it's moldy.
Oh,
Yeah, it
we
looks,
got fat.
it looks
I literally,
like
I want
silver.
to take it.
If it's creating silver, does that mean that you
You're
can
like,
just go to
okay.
a pawn shop and be
Yeah.
like, hey, I got some silver?
That looks so good.
No, I would never do that with the district's money.
What?
Shoot.
That sounded like a lie.
What do you mean it sounded like a lie?
No, I would never.
I would
never money.
So what you're seeing formed on the copper metal here, ladies and gentlemen, is actually silver metal.
I would eat it.
Yes, the stuff they make jewelry out of.
I would eat it too.
You know what? Nothing tastes better with breakfast than silver.
Man, this
That's
is
what
okay.
I'm saying.
this is the
Silver.
greatest example of survival.
However, ladies and gentlemen, if you are part werewolf, I would avoid it.
Oh boy, I gotta avoid it, y'all. I'm
Okay.
full mineral.
So now, does this reaction actually happen? Yes, it's happening right in front of our eyes.
Who said no?
So,
What?
look at the side that says activity series of common metals. Find me the two metals that we're dealing with here, which are copper and which are silver. Where are they at on our list?
Stop. You're weird.
Copper reacts with oxygen.
Don't worry about anything on the sides.
Oh,
The column straight down the middle.
well, copper's the sixth up from the bottom.
Okay, where's silver?
Fourth up from the bottom.
Okay, here's the way this works, ladies and gentlemen. Up at the top, you write most reactive. Down at the bottom, you write least reactive. What is the most reactive metal on here? Lithium. What is the least reactive metal on here? What? Gold. Why do you think they make things out of jewelry and things out of gold? Why? It doesn't react with anything. Doesn't react with anything. It's not going to tarnish. It's not going to change its color. It's not going to react with other elements. So gold is down near the bottom. So here's the important part. The element that is alone on the reactant side has to be higher up than the element in the compound on the reactant side for this reaction to happen. Okay? So this reaction that we wrote here happens. Now we would need to balance it. To balance it, I would have to put a 2 in front here, a 2 in front here. If this were our reaction, if we took silver metal and put it into copper nitrate, what would be the products?
Copper and silver.
Nothing.
Oh yeah. Yeah,
Because the silver cannot go in and kick out the copper. So literally, you would write no reaction. And you would be done. You don't have to balance it. You don't have to write what the products are going to be because the products are already here. This is not going to happen. So all we need to do is write write no reaction.
What if you just make it happen?
You could. You know how you could make it happen? You would have to add energy. In other words, this reaction, think of it this way. This reaction is like skateboarding downhill. It's going to happen on its own. This reaction is like skateboarding uphill. Okay? You got to put in energy. You can make this happen, but you would have to put in energy. We're not going to worry about that right now.
So what happens when I do force to happen?
Then you would get silver nitrate and you would get copper metal back.
Oh, okay. So I was kind of right.
So those are the only things that can happen here. The difference is this one will happen because we're going to a lower energy state. This one will not. Okay? This one will not. All right, Cynthia, please come sit over here. I've asked you guys 4 times. I'm sorry, I'm done. I'm done. Right? Questions? Thank you. All right. So, ladies and gentlemen, back to this. The way we identify it is you've got an element and a compound on each side of the equation. Element, compound, compound, element. I don't care what order, but you've got an element and a compound on both sides of the equation. That is what you have, ladies and gentlemen. That is a single replacement reaction. Questions? Okay. In Google Classroom, ladies and gentlemen, there is an assignment for today.
Okay.
Go to the classwork tab, predicting single replacement reactions. Click on that document and open it up. Okay? So, you are going to write what happens if these are your reactants. So, ladies and gentlemen, we need to find zinc and tin on our activity series. So we need to go to this sheet and find zinc and tin. Here is tin, SN. Here is zinc. Will this reaction actually occur? Will zinc replace tin? Again, here's zinc. Down here is tin. Does this reaction occur? Yes. Zinc is the lone element. It is more reactive than tin, so this reaction will happen. Okay, so if this reaction happens, what, ladies and gentlemen, are the products? What's the charge of zinc in a compound? Zinc is a +2. What's the charge of nitrate, NO3? -1. Writing a compound for it gives us Zn, NO3, 2. What state of matter would it be? AQ. Then what is the other thing that is created here? What state of matter? Metal. Okay? Now, what do you do if no reaction occurs? What do you do if it is not more reactive than the other one? You write down no reaction. Move on to the next. Okay? Questions? So, you have got this to work on, ladies and gentlemen, including down at the bottom here, writing a balanced equation for cobalt metal. By the way, cobalt metal, how would you write that? CO. Okay? Now, we would write it CO metal. So why am I telling you a +2 ion in the compound? Well, cobalt is one of those that when you look at the periodic table, you don't know its charge. So I'm not telling you this reaction happens, but I have to tell you what the charge would be of something that you can't find its charge on the periodic table. So if you see a compound or a note like this, it means if this goes into a compound, this is the charge that it is going to have. How do we write aqueous lead-4 nitrate? How do we do lead-4 nitrate? What's lead? What's its charge? +4. That's what the Roman numeral means. Nitrate, what's the formula? So what would be the compound? All right. So what would change places with what here? Cobalt and the lead. On your sheet, find me cobalt. Where is it? Like in the middle. Where is lead? Above it or below it? Below it. So does this reaction occur? Okay, so now on the product side, what do we get? Okay, lead metal is going to get kicked out. It's going to be alone. Okay, cobalt is a +2. Nitrate is still a -1. So how would we write that? Now, what do I still have to do to this even after I've written the products? You still have to balance it. Now, if there's no reaction, don't waste your time balancing it. You don't need to. You just write no reaction, you move on to the next one. Since this one, there is a need to balance, I'm going to have to put a 2 in front here and a 2 in front there to get it to balance. You will balance it. If it doesn't happen, you don't need to balance it. Questions? So you've got this, ladies and gentlemen. If you haven't finished your other worksheet on just the balancing of equations, you have that to work on. If you have questions, I will be happy to answer them, ladies and gentlemen. Otherwise, please find something to work on, ladies and gentlemen, and please let me know if there's anything that I can help you with. Go to work, ladies and gentlemen.